Good evening. Today is Wednesday, November the 18th. Today in geometry, we looked at some transformations. So I'll go to the share screen with the whiteboard and show you some examples of what we did. Now, in most cases, what you're looking at today, if you look at the types of problems, is basically you are asked to recognize the types of transformations that are taking place. So it's not a very algebraic intensive type of lesson. So look at the screen here and I'll show you what we did. Now, so the first thing we do here, I will draw ourselves a set of axes here. So here's my y-axis, and then my x-axis is here. And then we'll put us a triangle in here. So let's draw us a little triangle here. Let's say we've got, let's say this is going to be about 0.21. We can go up here to, 5.5. And we come back down. Let's say this is 4.3. And then we come from down here to right here. Okay, so we'll look and say this is coordinates 2, 1. Okay, and this will be coordinates 5, 3. And up here, let's say we have 6 and 7. So this will be 6 and 7. Now, so we have 3 types of transformations that we'll look at. Okay, 3 types of transformations. Come down here. The first one is, and these are what are called congruent transformations. So I should put, I won't do that. Undo, okay. Here, I'll just put it in again. Okay, 3 types of right, because the reason why they're called congruent transformations, because when you do these transformations, the shape and size of the original figure is maintained. So the first one we would have down here is a translation. The second one would be a reflection. And then the third one will be a rotation. Okay, now, so if I look, when I do a translation, let's say if I want to do a translation here, and I want to do a translation with what we would do, let's say 5 comma minus 2. Now notice this kind of looks like a set of coordinates, but it's got brackets in it. So what that means is I'm going to take my picture and I'm going to move it 5 units to the right. I'm going to move it 2 units down. So if I come over here to each one of these points, so I can look here and I can say, okay, I've got 2 comma 1, and I add to that 5 comma minus 2. Then my new set of coordinates is 7 comma minus 1. Now I do the same thing with each one of the original coordinates. So like I can come in here, the second one would be my 5 comma 3, and I'm going to add to that the 5 minus 2. So I would get a new set of coordinates, which would be 10 comma 1. And then the third set would be, we've got our 6 comma 7, so 6 comma 7 plus 5 comma minus 2, and that equals to 11. I gotta put my parentheses, 11 comma 5. Okay, so if I drew this new figure here, it would be a triangle, and the triangle would be the same shape as this, just shifted over to the right and down. So now, so that's translation. Translation, you just take and move it right and down, left and up, left and down, but it's a two-way shift. So I'll go ahead and I will erase this down here so I can show you what we've got coming next, which is a reflection. Now, so I can reflect about the x-axis, or I can reflect about the y-axis, or I can reflect about a line y equals x. But if I reflect about the x-axis here, for instance, I would come down vertically if I just kind of drop myself down right underneath here to a point which is similar. So let's say this point right here is 2. Now notice if I reflect about the x-axis, the thing that changes is the y-coordinate, and it will change from plus to minus. So this one here would come down like this, an equal distance. So it'd be a point about right here. And this is going to be the point 5 comma minus 3. Once again, the y-coordinate changes, the x-coordinate does not change. Now, if I drop this point down, just kind of dash you a vertical line down here so you can kind of see about where it goes. See, it's down here at, this would be about 6 comma minus 7. Okay, now, so if I come back up here and do my line, so I can do my line from here to here. I can do my line from here to here. And I can do from my line from here back up to here. Now, if you notice, if I had been using graph paper, which is what you want to do when you're trying to do these transformations, it makes it a whole lot easier. Then you can see that this triangle and this triangle will have the same shape and the same size. That's the reason why they're called congruent transformations. You transform it. There will be some other transformations later on that will not result in congruent figures. So that's the reason why the congruent expression is part of this original statement here. Now, so the rotation, the simple thing to look at with a rotation here, let's say if we're going to rotate this figure here, so that we've got a line here, which is y equals x, which should be about right up through here. This is a y equals x line. If I rotate it 90 degrees, I would be going right back up in this direction with a y equals minus x line. So what you're going to do here, if you're going to rotate this figure, you would take a line that goes from the vertex down here to the origin, and then you would run a second line up in this direction here so that it's perpendicular. So that's perpendicular, and I would go out the same distance here. So I would put a point about right up here. That looks about to be the same distance, right? That distance from there to the origin and from here out, okay? And if I do the same thing, now I can ignore, let's see, I can ignore this line right here. Let me see if I can undo. No, I can't undo. Okay, I'm going to put the point back up here. And what I'm going to try to do is I'm going to try to that's not working. I'll put the point here, and I will try to erase this line right here, right? Okay, good. Now, and I will erase this line right here. Okay, so now I got my point, right? Now I go back to here. So if I draw the line from here down to the origin, and I make a 90-degree line here, and I'm going to do that. Make a 90-degree line here so it kind of looks like it's going right up like this. And then I can kind of measure off this distance here. So I can get, let's see, that's about like that. So I can put my point right there. Okay, and then I can go erase this line and that line. And then my third point, I do something similar. I take a line from here down to here. And then once again, I've got to make a perpendicular line that goes from here. So I can go out like this, and notice it kind of just misses that other thing. And I can go out something like this right here. Okay, and I can put that point, which would be somewhere about like that, right? So now then I can erase that line and that line right in there. And now what I can erase this line and this line, and then I can go and draw my triangle here, which looks like this, and looks like this, and it looks like this. Okay, now here's the thing you want to look at. When you look at this, what you will find out here is the coordinates to this point right here appear to be, and if you do this on graph paper, you'll find out it's -1 and 2. So what you've done is you've taken the coordinates in the first quadrant here, the 2, 1, you've reversed them, and you've put a negative on the x coordinates. So if this point right here would be, this point right here would be the reciprocal of that. So this point right here would be -3 and 5. And then this point right here would be -7 and 6. And that's the biggest thing when you start this rotation and reflection. You want to be able to tell exactly what type of, or what's happening to the coordinates. Now, the interesting thing here, if you rotated this thing 90 degrees, which means you would go straight, I mean, not 90, but if you rotated it 180 degrees, you would go like this, and you would go down in here, and the 180 degree rotation would reverse, no, it wouldn't reverse, it would make each one of these coordinates negative. So you'd be down in here, and you'll find out that the 180 degree rotation would be the same thing as reflecting about the x-axis, which we've done here, and then taking and reflecting this about the y-axis. So you would get down here, you would have -2, -1, you would have -5, -3, and you would have -6, -7. So, but as I said, the thing that most of the problems that you'll be doing in your homework today is you're looking at just seeing what type of a transformation do you have. So that's That's pretty much the lesson that we did today. As always, if you look at your homework, if you have questions, if you'll send me an email, I will get back to you. So I'll go ahead and stop sharing here, and I will see you tomorrow evening.